Good morning, viewers at home. This is Mathematics with Dr. OJ. In this video, we shall study arithmetic mean. Kindly subscribe to my video channel by clicking the subscribe button below the video and the notification bell so that each time I upload new video, you'll be duly notified. Thank you. Arithmetic mean. The arithmetic mean of two numbers A and C is the number B between A and C in the arithmetic progression. That is, before we can have arithmetic mean, the progression must be arithmetic. There must be what we call common difference. Okay? Thus, if A, B, C form an arithmetic progression, or arithmetic sequence, then the common difference D will be, remember, for us to know the common difference here, in our last video we talked about how to get the common difference. Now, if A, B, C form an arithmetic sequence or arithmetic progression, the common difference will be B minus A or C minus B. It will be, you subtract the preceding term from the succeeding one. Okay, B minus A, you can call that one equation 1, or the common difference could also equal to what? C minus what? Minus B. You can call that one equation 2. Okay, so now for us to eliminate D or whatever, in fact, obviously to eliminate D here, we can equating 1 and 2. There are ways of doing this, but let us suppose we equate 1 and 2. So because D is equal to B minus A, D is equal to C minus B. So for us to now eliminate D, we can say what? Let B minus A be equals to C minus B, because D is common to them. So in this case, this B will come here and become what? B plus B is equal to C plus A. I hope you understand that. By the time you bring B from that side to the left hand side, you have B plus B. So which invariably will be what? 2B is equal to C plus A. And how do you get B here? B will be equal to what? C plus A all over 2. Which is the same thing as half over C plus A. Okay? So the arithmetic mean B is equal to C plus A all over 2, or half into C plus A, or A plus C. Now let's look at an example. Let's say example 1. Find the arithmetic mean of 4 and 16. Find the arithmetic mean of 4 and what? And 16. Okay? Now, how do we find the arithmetic mean of 4 and 16? Let's look at that. Now, solution. I say let B be inserted between 4 and 16, such that okay, such that 4B 16 form arithmetic sequence, so that it forms arithmetic sequence. And we obviously know that b, to know the common difference, b minus 4 will be equals to 16 minus b. I hope it, just like the earlier example when we were illustrating the arithmetic mean. So b plus b is equals to 16 plus 4. 2b equals to 20. B is equals to what? 20 all over 2. So b is equals to what? Is 10. So now in that case, our b is equal to 10. It's as simple as that. Okay, now let's look at an interesting example here. Without going through that stress, we could equally apply the formula by using b is equals to c plus a all over 2. So we still get the same thing. You ask why? You can say that since b is equals to a plus c all over 2, I think, which is our a is 4, then plus our c, if this is a, b, c, 16 all over 2, that is 20 over 2, which is 10. So it's still the same thing, okay? Now, another example here is example 2. Example 2. If x squared, y squared, z squared are in the arithmetic progression, if they are in the arithmetic progression, okay, show that 1 all over y plus z, 1 all over z plus x, and 1 all over x plus y is in arithmetic progression. I want to show that this is an arithmetic progression. So now this is a very interesting question or an example. An interesting example. Let's look at how this could be solved. Okay. Now, if x squared, y squared, z squared are in arithmetic progression, show that 1 over z, y plus z, 1 over z plus x, 1 over x plus y is in arithmetic progression. Now, for a set of numbers to be in arithmetic progression, there must be a common difference. Okay? So that means for these three terms to be in arithmetic progression, there must be what? Common difference between them. So what will happen? So we have the A, B, C, or first term, second term, third term. Okay? So and since D is equals to T2 minus T1 or T3 minus T2, that is the first term, so be subtracted from the second term. The second term will be subtracted from the third term. So we have 1 all over z plus x minus 1 all over y plus z will be equal to 1 all over x plus y minus 1 all over z plus x. Okay? So we can find the LCM of this. Z plus x, y plus z. Find the LCM of this as well. X plus y, z plus x. Okay? Remember, they are equal to each other. So z plus x cancelling z plus x, yeah, we left it what? Y plus z. So times 1, y plus z. Then minus y plus z cancelling y plus z, will be left with z plus x, yeah, times 1. Z plus x. Okay? The other one, x plus y cancelling this, you have what? Z plus x left, multiplied by 1, z plus x. Okay? And z plus x cancelling z plus x, we left with what? X plus y times 1. X plus y. Okay? You might put it in bracket if you like. No problem. So now let's open the bracket here. Y plus z, then minus z minus x. Alright? By the time you use minus 1 to expand the bracket, you have that. All over z plus x into y plus z. Okay? That's equal to Now z plus x, then you open the bracket with minus 1 here, it becomes minus x, then minus y, all over x plus y into z plus x. Okay? Now we have, by simplification, plus z we cancel minus z there, and minus plus x we cancel minus x here. So we left it what? Y minus x all over z plus x into y plus z is equal to z minus y all over x plus y into z plus x. So looking at these two fractions, both the left hand side and the right hand side, something is common here, and what is common here is z plus x. So we can factor out z plus x, 1 all over z plus x. This one will be left with what? Y minus x all over y plus z. Okay, is equal to 1 all over z plus x as well. We'll be left with what? Z minus y all over x plus y. So 1 over z plus x, we cancel 1 over z plus x here. So we left with what? Y minus x all over y plus z is equal to z minus y all over x plus y. So the next thing is what? Is to cross multiply. The next is to cross multiply. We now cross multiply. So by the time we cross multiply, we're going to have cross multiply gives, okay, y minus x into brackets x plus y, that is cross multiplication, all right, is equal to z minus y into bracket y plus z. Okay, by the time we expand this, we have yx, because y times x is yx. Then y times plus y, that's plus y squared. Then minus x times x, minus x squared. Then minus x times plus y, that's minus xy. Okay, is equal to z times y, zy, z times plus z squared, minus y times y, minus y squared, minus y times plus z, that's minus zy. Okay, so here looking at this, you see that this one we cancel this. Yx minus xy, that's 0. So let's what? Y squared minus x squared here is equal to zy, we cancel zy here. We have z squared minus y squared. So looking at this critically, one will see that this is more or less saying x squared. This is now correspond to x squared, y squared, z squared. So you can see that you can simply form, these are simply formed arithmetic sequence, because the common difference there will be y squared minus z squared, which is this, which is same thing as z squared minus this actually formed. The results as corroborated the fact that 1 all over y plus x, there's 1 over y plus z, and 1 over z plus x, and 1 over x plus y, and AP. This thus, we cannot say, thus 1 all over, 1 all over y plus z, comma 1 all over z plus x, and 1 all over 1 plus x plus y are in AP, because the results of the solution gives us the confirmation that x squared, y squared, z squared, which was in the original question, are in AP. So that is that for that. So thank you very much for watching. God bless you as you subscribe to my video channel.